Hello, welcome to our Best in Show FME Tips and Tricks for Productivity webinar. Now, the videos shown here today can help make you more productive, but if you're looking for like a formal training session, this is not your webinar. We do have a lot of those available on safe.com/webinars or in the FME Academy. And if you're looking for a webinar that's going to teach you some amazing things about FME, but also might have a bit of horsing around, then this is definitely your webinar. My name is Stephanie. You've probably seen me around on some webinars before. And if not, you might have seen me in your emails. And if you notice, in emails, I refer to myself as the webinar wrangler at Safe Software. And that was kind of an inside joke to myself because when I'm not wrangling webinars, I'm wrangling horses. So this here is my horse Flynn, and we are so excited to take you on a ride with us today. We're going to start our ride with a tip for FME Server, move to FME Desktop and learn things like dynamic workspaces and get a speedy performance tip. Then we're going to head over to our mobile apps and we might hear a spooky mystery there. Finally, we're going to finish back in FME Desktop and wrap up with some live Q&A. My tip for the day is going to be to take advantage of the questions panel in GoToWebinar. Our webinars provide a unique opportunity to get instant feedback from our team of amazing experts, and it can end up saving you a ton of time and increasing your FME knowledge. I'm going to challenge everyone here to ask at least one question, or even just leave a comment like, hey, your horse is really cute. I'm still waiting for those to pour in. I expect they will start flooding in. So please test that out, get your questions in. We'll try to answer as many as we can behind the scenes and then do our live Q&A at the end. And with that, let's kick it off and I'll talk to you behind the scenes. So over to you, Sienna.
Teddy. Hi, my name is Sienna Emery and this is my puppy Teddy. We're here today to talk to you about using FME Server Parameters in FME Desktop.
So that was a great introduction by Teddy, but as you can see, he has something more important to do, so for the rest of the presentation, it will just be me without Teddy. So let's get to it. I think it's really important to talk about FME Server Parameters and how you can use them in FME Desktop to make your life easier. Let's begin by talking about what is an FME Server Parameter. An FME Server Parameter is any parameter that's set in FME Desktop to reference an FME Server component. This can be super useful if you're referencing data within an FME Server data directory, but you want to set it up on FME Desktop to look into a directory as well. If you know you want to reference that FME data directory once you're on FME Server, setting it up in Desktop is a very good idea, because when you go to publish, all your parameters will be already set up. You don't have to change a bunch of parameters once you go to publish your workspace. So just to reiterate, FME Server Parameters reference FME Server system settings. So I use the data directory as the most common one, but there are other ones you can reference as well. So if you're referencing a specific topic message in FME Server or just getting the FME Server host name, you can use that in FME Desktop as well. The best thing about using FME Server Parameters is you can set them up in FME Desktop, so you can give them a test value to work with in FME Desktop for your workspace to use. This is super handy because it will mimic your FME Server environment, which makes troubleshooting in FME Desktop so much easier. The geometry parameter isn't necessarily an FME Server parameter. However, it's mainly useful on FME Server. What it does is when you use the geometry parameter in your FME workbench, then you go to publish your workbench to FME Server, the user running the workspace will be able to open up the geometry parameter and select a web map with the location that they'd like to use in the workspace. This is super useful if you're sending your workspace to other users and they'd like to select a new location every time for the workspace. For my demo, I'm going to make a workspace to find the nearest dog park. To do this, I'll have to have a file saved locally with the locations of all dog parks across Vancouver. So how do I make a workspace in FME Desktop knowing that my file will eventually go to FME Server? How do I author my workspace in FME Desktop so it's accessible in FME Server as well? Well, the solution is to use FME Server Parameters, and I'll go through that in my workspace. On the screen, I have my workspace in FME Desktop. The first thing I'm going to do is add in my reader. So I'm using map info tab files. After I found the files locally, I'll add in my reader. Now I'd like to make use of the FME Server Parameters. So if I open up the FME Server Parameters tab, I can see the one that I'd like to use. In this case, it's the Shared Resources directory. I can double click and I can set a directory for that to use. I'd specifically like it to go to my data folder. Now I can reference this directory in my parameter that I already have set up. I can remove up to this data portion of this and add in my FME server directory. If I click OK and OK again, I should be able to run this. Next, I wanted to briefly touch upon using the geometry parameter in your workspace. Simply go to the Navigator panel, find your user parameters, and right-click to manage parameters. Next, click the plus button and select Geometry. From here, you can decide which geometry encoding you'd like to use. You can select what geometry types you'd like to accept: points, lines, polygons, or boxes. Finally, you can specify the bounds for your map. So let's say you don't want to give the user the option to select the whole world. You want a very specific location. You can select a bounding box within here. Next, I just wanted to point out, if you are using the geometry parameter, you should also use the geometry replacer. The geometry replacer will take that parameter and then turn it into geometry for your workspace to process. The final thing I wanted to show off was how to publish this up to FME Server. So first I'm going to select my data files to use. I'm going to specify a location. So I want to go to my data folder, but I also want to create another folder named Parks. I select OK, and then OK again. It's going to give me a warning, but that's safe to ignore. I publish this up by only selecting the data streaming process. Now I can head into FME Server. The first thing I'm going to do is check that my Parks folder has been created. I'll refresh the page and make sure it's there. From there, I can run my workspace. So I go to the Run Workspace page and find my new workspace I've created. I'll select the map, which was created with my geometry parameter, and I'll go to the correct area. Next, I'll place a point down. This point would be where I'm currently located, and this should tell me where the nearest park is to me. I hope you can see now that it's quite easy to use an FME server parameter in your workspace, and allows you to make the transition from FME Desktop to FME Server much easier.
Hi everyone, my name is Holly and I'm an FME Server Support Specialist at Safe Software, and I am also the auntie to my assistant for today, Frankie, who is a 5-year-old Pomeranian. Frankie is going to be handling the trick portion of this presentation, and is going to start us off by demonstrating the perfect rollover. I can see she's keen to get started, so don't blink or you might miss it.
Well, that was a hard day's work for Frankie, and she's now back on the sofa already dozing off. For the next few minutes, I'd like to walk through the steps I use to help me compose JSON queries for reading in more complex JSON. In this example, I'm going to be using the Pet Finder API, which returns information stored as a JSON string on the list of available pets for adoption. I would like to pull the contact information out into attributes in FME. So JSON is a lightweight, easily readable format that follows a standard structure, making it easy for FME Workbench to digest. The challenge is that depending on the structure, it can be difficult to identify the initial query needed to fetch the key value pairs that are of interest to you. So before we dive into a quick demo, let's take a look at the different components of a JSON string. First, what we know as an attribute name and value in FME is known as a key value pair. So for example, for our first pet, the species is a dog. For the JSON I am working with, all of the information is stored in an array. You can think of an array like a list, where there is an element for every different pet that's up for adoption. Within an array, we can also have objects which group a series of key value pairs together. Both objects and arrays can be nested. So for example, I have an object for contact information within my array, and the second object sits inside this, specifically breaking down all the key value pairs associated with the address. Let's take a look at how we can use FME Workbench to identify the query needed to pull the contact information out into attributes. So in my Workbench, I already have an HTTP caller set up, and in my response body, I have my entire string of JSON. And as you can see, this is pretty overwhelming. I wouldn't really know how to get started in pulling out that contact information. So to help guide me, I'm going to start by adding a JSON fragmenter transformer to my Workbench. And all I'm going to do is set the JSON attribute to that response body, and I'm not going to change anything else at this point. I'm going to run the translation, and it's actually going to identify the JSON array, and the array name is animals. And this is basically the array that is storing all of the information that is of interest to me. So now I can go back into my fragmenter, and I'm going to edit my query, and prior to the asterisk, I'm going to enter animals. I'm going to select OK and run my translation again. And at this point in our response, we're going to see the JSON has now been broken up so that each individual element in that array or each individual pet has been broken down into an individual feature. So we now have in our response body just the JSON specific to that pet. So now how do we go about pulling out the contact information? Well, what we're going to do is go back into the JSON fragmenter, and I'm going to set flattened query results into attributes to yes. Select OK, run the translation once more, and this time I'd like you to focus on the feature information window on the left-hand side. And when I click on one of my features, you'll see the number of attributes now jumps up. And what this has done is I've now flattened out this JSON so that every single attribute is listed here. And I have some attributes or key value pairs at the top level of my array. So these are just indicated by a single attribute name. However, what about the attributes or key value pairs that are stored in objects? Well, I can actually see this in here as well, and these have the object name as the prefix to the attribute name. So for example, I have the object breeds, and this contains 4 different attributes within that object. And the same thing for my contact, and then there was a second nested object in there. So this time I have 2 objects separated by periods before that final attribute name. And we can also find nested arrays in here. And since these are considered as lists in FME, you can identify these easily by this curly bracket symbol. Okay, so now we've got our address information. How do we actually pull this out so it's usable downstream in the translation? We can do this by using an attribute exposer. And thanks to some new data awareness in FME 2021, we actually don't need to know the exact name of all of these attributes. They're already listed for us here. So for example, I can pull out my postcode, and now I have this information available to me. But it's still stored under this contact and address. So what happens if I actually don't care about any information apart from what's stored in that final object? In that case, I can go back and edit my JSON query even further. So now I know it's stored under the contact object, and I know it's stored under the address object. And this time I don't need to add in an asterisk. That's really just for the purpose of arrays. So I can select OK, run my translation again, and this time the response body only has the information specific to that object. So now in my attribute exposer, I no longer need to specify this prefix, and instead all I need to specify is the postcode information. And attribute exposure is also something that can be done directly in the JSON fragmenter, but this just isn't data aware just yet. So tip number 1 is to make use of feature information to help identify the JSON query that you need. And my second tip is to help you remove the need for attribute exposure. So in the HTTP caller, I can save the response body to a file, and then I can add a feature reader. And a feature reader has the option to specify a query, just like the JSON fragmenter, but the reader has the added value of exposing all of the attributes for you. So at this point, I have access to all the information about every pet within this JSON string. Okay, so that's it from me. So thank you very much for tuning in.
Hi, I'm Sam Walker, the Customer Education Team Lead here at Safe Software.
And I'm Annabelle Glass, the Product Manager for Desktop Authoring. And this is Honeybun, a retired racing greyhound from Florida we adopted 3 years ago. Her breed is one of the world's fastest land animals, so let's see if we can learn some FME performance tips from her. Is your workspace too darn slow? Are you tired of all the waiting around? Let's ask Honeybun, retired racer and performance specialist, to show us how your workspaces can go from running like this to running like this. Let's improve the performance of this workspace that calculates a walkability score for addresses in the city of Vancouver. One of the main ways to speed up your workspace is to read the minimum amount of data. Reducing the amount of data you read means you won't waste time processing data, only to get rid of it before writing. One way to quickly reduce unnecessary reading is to use a where clause when reading database formats. In this workspace, we can double-click on our Esri GeoDatabase reader feature type and set the where clause to postal code like V6 wildcard. This clause tells FME to read addresses from a subset of postal codes. It's faster than reading them all in and then filtering them using FME at design time. Delicious! Fast workspaces are my favorite treat. Another performance tip for reading is to remove unnecessary feature types. It looks like the original author read in the postcode boundaries and parks feature types at one point, but we aren't using either in the current workspace. Simply delete them to avoid reading unnecessary data. Ah, a clean workspace makes me smile. If you aren't careful when authoring workspaces, you can quickly end up with many unnecessary attributes on your features. These extra attributes slow your workspace down. In this workspace, the aggregator transformer is reading a list attribute on over 9,000 addresses. If we inspect the data, we can determine we don't even need this list attribute. Let's set up the parameters to stop generating the list. This step will save valuable time. We are still developing our workspace, so feature caching mode is enabled. This mode lets us inspect our data at any point in the translation. However, generating these caches can cause quite a performance hit. What if I told you it was possible to keep feature caching enabled, but also improve performance? I don't believe you. No way you can have your kibble and eat it too. Let's collapse the prepare addresses to join bookmark by clicking the arrow next to its name. When collapsed, we can run the workspace with feature caching and only generate caches for connections entering and exiting the bookmark instead of all of the output ports. This step will let us keep feature caching on while stopping unnecessary caches from slowing us down. Oh look, it's beautiful! Just like me. With all of these performance improvements, we are off to the races. Now that you've improved your workspace performance, you can finally relax, honey bun. I'll use all of this saved time to catch up on my beauty sleep.
We hope you've enjoyed these tips. Thanks for the help, honey bun. You can learn more about improving workspace performance and earn a badge in the new Use Data Integration Best Practices learning path on the FME Academy, accessible at community.safe.com/s/academy. Thanks.
Hi everyone, I'm Tiana and this is Joey. Good boy. And we're here to teach you one of the most useful things to know about authoring workspaces, dynamic workflows. So when you're building a workspace, sometimes it helps to have flexible feature types that can accept any schema or data model. Typically, feature types are tied to data that has a specific name, set of attributes, and geometry types. Like this one accepts an Excel sheet called Joey's Friends with a specific set of columns, and it writes a file with the same data model. But in a dynamic workflow, you're allowing flexible data into the workspace. So even if the structure of the source or destination data changes, the workspace can still handle it. This dynamic workspace can handle any spreadsheet. It doesn't have to be called Joey's Friends, and it doesn't need to have specific columns. So you can think of it like Joey's Kong toy. This is designed to put treats inside, and it's like a dynamic feature type because it not only accepts peanut butter as an input, but it also accepts cheese and bacon and kibble inputs. It makes a flexible toy that we can get a lot of use out of. So if you're building a workspace and you notice that you have a lot of different feature types going through the same transformers like this, or like this one, note that it would be a lot simpler if you just had one dynamic feature type, like this. Something nice about a dynamic workflow is that if the source data model changes, you don't need to update the workspace because it's already designed to accept any data model. There are a few ways to create a dynamic workflow depending on what you need. The most common type is when we want to make the output mirror the schema of the input. So to do this, use the Generate Workspace dialog and toggle the Dynamic Schema option. This tells FME to be flexible in what kind of schema it accepts and to generate the output schema dynamically at runtime as a mirror of the source dataset. So this workspace's purpose is to translate Excel to shapefile. When I run it, it's flexible in terms of what Excel input it accepts. So I could pass it a spreadsheet called Joey's Toys with a few columns, and the output dataset will have the same feature type name and the same attribute names. I could also pass it a spreadsheet called Parks with 10 columns, and it'll do the same task. You can also make a workspace dynamic when you add a reader by choosing single merged feature type. Or when you add a writer, you can choose to define the feature type dynamically or generate it based on an external template. When the workspace runs, FME will get the schema from the place you specify and use it for the output. We have a whole tutorial series on this if you go to the FME knowledge base, so check it out to get step-by-step instructions on the different ways to make workspaces dynamic. I also wrote a blog post about this if you want to learn more about what dynamic workflows are and why they're useful. And my coworker Brian demonstrates how to do this in our Schema Drift webinar. So to sum up, a dynamic workflow is a flexible way of building a workspace that can really simplify the number of feature types and transformers on the canvas, as well as the number of workspaces that you have to maintain. It's a way to perform the same translation and transformation on the data, regardless of the input data model, which makes it particularly useful for self-serve data portals and any other scenario where you don't know the data model upfront. And that's it for us. Good boy.
Hi everyone, Brian and Penny here, and we've got an FME tip for you.
Now Penny is a fun-loving dog. She's a golden doodle. We've had her for about a year, and one of the things she loves to do is dig holes. You can see she's done it in our backyard. She does it at the beach. She does it everywhere she can. Sometimes she even likes to do it with friends. So, Brian, how does this relate to FME? Well, I'm going to show you. It reminds me of a story that we told on the FME World Tour in 2016 from Jared Stutzman at Devon Energy. And the reason that it reminds me of FME in the story is because they were also digging directional wells and then modeling them using FME. A directional well is curved, and so to recreate the data, and when they survey the data, they don't actually have the shape of the well. They have mathematical calculations to recreate the shape of the well. And so what that actually means is each record here on the left is a little bit of a mathematical algorithm to place a point in space, which then FME is being used to place lat and long coordinates to be able to recreate these wells. But the trick is you actually have to reference the data, the feature before the current feature, to be able to calculate and place those coordinates. And there's a little trick in FME that you can use to do this. And it's called enabling adjacent features. And this is in the attribute manager. And what it does is it allows you to reference attributes in a previous feature of the same data set that you're working with, either previous features or even features that are coming up in the data set. And that's quite unique. FME is very much, here's the record, do work on that record, and away you go. But in this case, you can turn this on and you have a bit more of extra power. Now, in Jared's case, they had a very crazy algorithm here. We won't walk into this too much, but the key thing to notice is that there is this feature -1 thing. And what this actually is referring to is the previous feature's attribute in this algorithm so that you can calculate the spot on the well survey of where the point actually is. So let's look at this in FME. And I'm going to create a demo here to showcase this feature, and we'll just do it in a bit of a simpler way so you can understand this in practice. So we've got some rainfall data. It's in an Excel data set, and it's cumulative. So every month we're adding up the records together. And what we actually want is just the monthly totals. We don't want this cumulative data in our result. And so we're going to turn on this feature and we're going to try it out. Let's go to FME. Here we are in FME. And the first thing we want to do is just take a look at the data. Note that all the values are being added together. So what we're getting is a cumulative value at December for the grand total, but we don't actually know each month's representative values. So let's make a change here. We'll add an attribute manager to the mix. Pop that in. And here's where we can turn on this great feature. So under advanced, we can enable adjacent feature attributes. And note that you can go forwards to the future features, or you can go backwards to the previous features. And that's what we're going to do here. So we're going to go back one feature. And here we're going to create a new value. And I'm going to open the arithmetic editor here and put in my algorithm. And what I'm doing is I just have the current value and I'm subtracting the previous feature's precipitation value. So that's this feature minus 1. Kind of neat. And the only other thing to do is make sure that we have a default value. And that's clear because January, we don't have a previous feature to subtract from. So we want to use the 168 there. So we need the default to be kept. And we can run this. Let's see what we get as an output. So there we go. So now we know each monthly feature's totals and we are happy. And so whenever you have data that's like this, it's cumulative, or you need to reference future features or previous features, give this feature a shot. So from Brian and Penny, thank you very much.
Hello, my name is Dmitry. I work at Safe Software as scenario creation analyst, and this is Ollie. Ollie was born in Texas. He was found somewhere in the wild along with 21 other puppies, 2 moms. He was brought to British Columbia when he was about 7-8 months old, and he never looked back. He leads a life of a happy dog. Every day he goes for a hike with me to the forest, and today we will go there and we will collect a few landmarks with FME Data Express. FME Data Express is a mobile app that can run workspaces hosted on FME server. So we need a workspace to run the data collection on FME server. Here is the one that we will be using today. It's probably the simplest workspace I ever created. So we have a creator here to kick off the transformation. And then we have attribute creator that gets the parameters collected with FME Data Express. It copies them to attributes, and then we save this feature to Google Sheets. Maybe that's not the best geospatial format, but it's very easy to share, and I plan to share this workspace with everyone after the webinar. What I think is really important to highlight is how we collect geometries. So I open our parameter manager and go to this location parameter. Here we can specify how we would like to collect our geometry as GeoJSON or FME XML. And here we can select which geometries we would like to collect: lines, points, polygons, or boxes. So I pick the first 3. The next important step is to publish this workspace to FME Cloud so that it can be used as a web service. This is how simple it is on the desktop side, and I only need job submitter service, that's it. On the FME server side, we need to do just one thing. We need to create an FME Workspace app. Workspace apps is a convenient way of accessing workspaces through FME Data Express. I'm not going into the details of workspace publishing or web app creation. We have lots of materials in our documentation throughout the community. You can check it there. Ollie and I, go for a hike for some data collection. So this trail is called Blue Line. And this carving, blue face, it's a marking for the trailhead. I'm going to collect it first. I pinned the service that I created to my screen, so it's easy to run this up. Once I press it, it opens and I can fill out the parameters. The most interesting parameter for us today is location. So we press that icon looking like a map, it opens our current location, represented with blue dot. We add a point geometry, make sure that they match, and this is it. Then we can run this workspace, and the record is submitted to our spreadsheet. Now have a look at another icon I have on my screen. It's another workspace that reads the spreadsheet and visualizes whatever we collected and our current location. So this is our second landmark, which is called Grizzly Bench. On top of it, we have another carving, Trail Bro. So let me collect this landmark. So I'm typing all the text parameters. And let's have a closer look at the location parameter. I press the plus icon and get the geometries that we enabled in our workspace. This placed a point on the map, and now I press the blue arrow to match my current location with that point. And this is it. Now we can submit another location to our spreadsheet. So this is the trail that leads me to this lookout towards southeast. When the sky is clear, we can see Mount Baker from here. I'm not sure whether that should be counted as man-made or natural type of landmark, but well, let's make it natural just for a change. You can see here that FME Data Express did not allow me to submit a job without filling out all the attributes. This is a cascade of waterfalls over 100 meters high. You hardly can see it entirely because it's, well, deep in the forest. But I always wanted to know the shape of this cascade. So today our first linear feature will be this waterfall. We'll try to figure out its shape. I will start from the bottom and go to the top. Okay, this is a relatively flat place. Let's begin from here. Collecting lines is very similar to collecting points, but we also get some extra buttons at the bottom. Whenever we would like to add a new vertex, we press this plus sign. You actually can see me moving in the forest. With the arrows on the left, you can move between vertices and correct the location of previously collected vertices. It is very, very steep, as you can see. So if you ask why I'm in such a good shape, now you know why. I do it every day. By now it's pretty close to the top, but it's not over yet. So, and this is the top of our waterfall. Let's finish collecting our line here. So here comes the columnar section, and now we can submit our line to our spreadsheet. And now we are approaching our destination, our final point, not the last thing that we are going to collect, but the farthest point on our route. This waterfall, my precious. I call it my waterfall because Well, I never came up with a real name for it. Now you know my secret place in this forest. And this is an area feature we will try to collect. This is some unfinished construction. When I first found it a couple of years ago, I found quite a few cans of Molson laying around. Molson is a popular Canadian beer. So I imagine it went like this. People begin building this hut, then made a break, had a couple of beers, and then decided that it's okay like that, and they left it as is forever. And now we will try to collect it, I don't know, for future reference. Polygon collection with FME Data Express is similar to collecting lines. The difference is that we see the interior of the polygon as a light blue, semi-transparent filling. I visit all 4 corners of the ruin and take my vertices. With the last one I just added it to complete a rectangle because GPS couldn't find the proper location. That's forest after all. And this is it. Now let's have a look at the data we collected today. So this is the imagery of my neighborhood. We move to the forest. Here's our first one. Blue face, yes, that's correct. Then trail bro. Here is the ruin and the waterfall and our stream. This is actually called Noons Creek. And the last one was blue. What is blue? I had red for man-made and green for natural, but blue. Hot on chicken legs. Baba Yaga's home. Witch mate. No, I'm not dealing with witches. But I have a bird here at home who might have an idea.
Hi, my name is Lena. Let me introduce our flock to you. This is Clara, our green chick canure. It is a bit confusing. Her chicks are actually red, and every time you see a canure with red chicks, it's called green chick canure. And this is Murdoch, our African grey. We call him grey in everyday life as Murdoch seems to be a bit too ceremonial. They both are rescues, and we have no idea about their previous lives. Not their names, not who they lived with, not even how old they are. But as you might know, African greys are really good at mimicking sounds. And sometimes we hear voices from Murdoch's previous life. And we wonder, did you live with Baba Yaga before? Why Baba Yaga? If you heard Gray's evil laugh and cracked cough, you would be convinced too. I do believe it's exactly how Baba Yaga must sound. Let's see. Great. Do you like any of these models? Do you like this one with chicken legs? Sounds great. Let's bring it into the forest and see whether it really looks like your old home. Let's create an AR model using the HUD Gray selected. I have already added an FBX reader to my workspace and inspected the model. The size of the model is 200 by 200 units, which means it is in centimeters, and FMER requires it to be in meters, so we will scale it down. I also found out that in model coordinate system, the floor is at elevation 0, which means that when we will be loading the model, the floor will be put on the surface we detect. If we want the model to stand on the surface, we need to recenter the model so that the 0 elevation is at the very bottom of the model. We use model center transformer for that. Now the model is ready to be written as an FMER model. Let's add FMER writer, decide where we'll be saving the file, and check writer parameters. At the moment, there is only one parameter available, and it's initial model scaling. It can be set to either fit or full scale or custom. I set it to full scale so that when I load my model, it will be loaded in true 1-to-1 scale. As we know where the hut is located, let's create a geolocated model. To do this, let's add an anchor to the model. An anchor is either a no geometry or a point feature. This feature should have three format attributes. The first one is FMER_location_feature, and it should be set to anchor. The other two attributes are FMER_anchor_latitude and longitude. As walking around the model in the forest might be not that convenient, we might want to add a couple of viewpoints. Viewpoints will allow us to teleport from one place in the model to another place in the model. A viewpoint is also a special feature in FMER model. To create it, let's use attribute creator. We need to add FMER_location_feature attribute once again and set it to viewpoint. This feature has to have point geometry. This will be the point where we teleport. We could take one of the model points and use them. But in our case, we will simply type in X and Y coordinates and then use vertex creator to create a point. It is also a good idea to name your viewpoint. Let's use geometry property setter and set geometry name. This name will be your viewpoint name. Let's call it front door. To add one more viewpoint, we will simply copy the whole branch, change the coordinates to the coordinates somewhere at the back of the model, and rename the viewpoint. Our workspace is now ready. We can run it, create the model, and take it into the forest to inspect on location. We can now load the model using FMER application. As the model is geolocated, we can choose to load it at its true location, the one we set with the anchor, rather than just simply in front of us. Once the model is put in place, we probably don't want to see the anchor anymore, so we can turn it off. Let's take a look at the two viewpoints we created, the front door and the back door. We can easily teleport between the two viewpoints. Just tap on the viewpoint and we happen to be at the location of the viewpoint. Tap on another one and go back to the front of the hut. Let's now turn the viewpoints off. We can now walk around the model and enjoy the view. I wouldn't go inside though. What if Baba Yaga is still there?
Hey, I'm Kaylin, and this is Otis, my golden retriever, and we're going to show you how to get a background map on a PDF. So after talking with Otis, I think we're going to leave the tips and tricks to FME. So our tip is how to use the feature reader for pre- or post-processing data throughout a workspace. This is also included for the feature writer. Alright, so let's jump right into the demo. So for the sake of time, Otis and I pre-built the workspace, but our trick can be found in this bottom green bookmark here. The data we're using today is coming from the U.S. Forest Services, and it's showing fire occurrence locations in the state of California for the year 2018. Before jumping into any workflow, I like to recommend reading in the data just to make sure FME is interpreting it correctly, and this way you guys have a little bit more context of what the data looks like. I also would like to check the coordinate system because we're going to be overlaying this point data onto raster. So we can do that by checking the feature information window. So it's in spherical Mercator. We're going to want to reproject that. But first, let's go ahead and add a bounding box accumulator to create a 2D bounding box covering all our point data. And we can inspect that, and we can see now we have a bounding box down here. We'll use the reprojector to reproject to the same coordinate system our web map tile service is in. I'm aware of the coordinate system, so I just plugged it in, EPSG 3857. Then we're going to be using a bounds extractor to get the min and max x and y values of our bounding box. This is really nice because it separates it into separate attributes. Now we can use a feature reader to read in our web map. So this is the one I've selected. I've gone ahead and set up my web connection because it does require it through ArcGIS Online. If yours doesn't, that's totally fine. Just go ahead and use the one you'd like. The layer I'm reading in is USA Topo Map. I'm going to be rating the tiles in as JPEGs. I'm going to leave the matrix set as default, and I'm using an 8 tile resolution. If you need more or less detail, you can increase or decrease that value as needed. We're going to be reading the tiles in by bounding box, so we're going to use those output attributes from the bounds extractor and just feed them right into these values, or sorry, these fields. And hit OK when you're done. OK. OK. Oh, okay, so in here, I forgot to change. We're going to want to read data and schema features. And now we can see the tiles being read in. Let's just check it out. And you can see they're all individual tiles. Just going to close the visual preview window for now. We're going to use a raster mosaicer to create one raster out of all our tiles. And then we're going to use a vector on raster overlayer to overlay our point data. From here, I used the PDF page formatter in conjunction with everything else I had set up just to kind of generate the output a little bit faster, but this is a really simple setup. This is all I have in here. And then we're writing to PDF. So I'm going to go ahead and write that. Say today. Cool. So if we go and check it out, we should just have a simple PDF map, yep, with the title and overlaying point data. Awesome.